Good morning, ladies and gentlemen. Today we will be doing financial mathematics. But before we do that, we will start with a bit of background, what financial mathematics is about, what are the things that are important, and so on and so forth before doing necessary calculations. So we'll do some introduction, then later only do simple and compound interest. Now, let's start with what an interest is. An interest is an amount that is added to some particular investment or loan. So let's say, for instance, you put in 10,000 rands and then you tell the bank, no, why don't you keep this 10,000 rands for me and then I'll take it maybe after 3 years. Keep it, do whatever you want with it, but after 3 years, I want my money back. So the bank will obviously pay you for your contribution to them, or will pay you for lending their money to them at that particular point in time. So that amount that they pay you, or that amount that they add to your initial 10,000 rand, that is what we call an interest. So basically an interest is an amount that is added to some initial amount, that is some initiating amount. We will discuss the initiating amount in a minute. So when you're going to calculate interest, there are three basic or primary factors that are involved. The first one being that initial amount, which we call the principal amount. So the principal amount is the amount that initiates the whole execution process, meaning if you're going to take a loan, that principal amount will determine what the interest will be. The higher the amount, the higher the interest. Secondly, it's the time. Now, it should be noted that if you and your friend decide to borrow the same amount, and then let's say your friend says, no, I want to return this money next year, and then you said, no, I want to return it in 5 years' time. Remember, you are the one now who's going to keep the bank's money longer than your friend. So what we decide to do is what the bank decides to do is they say, no, it's not a problem. You can keep that money for 5 years, but when you pay it back, you should know that we are taking a risk for giving you this money for the next 5 years. So we will charge you more for keeping this money for 5 years. So, but what this means in short is, the longer you keep that amount, the longer the bank will charge you interest. If it was a loan, or it could also be vice versa. The longer you keep the money in the bank, the bigger the interest that will be added to your account or your investment. And lastly, we have the interest rate. Now, the interest rate is a percentage, or it's some fraction or some particular decimal or portion. Now, the rate, of course, is some percentage which will be calculated using some more advanced financial techniques, which we will not dwell into. We will assume that the bank has done all the necessary calculations in our case, and has already determined how much rate to charge you with, or how much rate to give you in your investment. So the interest rate is that particular percentage which will be calculated on your principal, and of course with your time, which will give you that final amount of interest. Now, all this interest, of course, once we've done our calculation, it comes to two things. We need to calculate that particular simple interest. Now, simple interest, of course, is some interest that is calculated from an initial investment. Now, we will discuss further what this means But what it, in a nutshell, what it says is, if you're going to calculate simple interest, I need to know how long this interest so how long you will keep this money, or how long the bank, we as the bank, will keep this money. How much is the money you are talking about, whether you're borrowing or investing, and then the bank decides how much interest to charge you if you're borrowing, or to give you, or to charge themselves, I should say, if you are investing. So we'll have these three initial variables. P, which will be the principal amount, that is that amount that initiates the investment. We've got a small letter t, which will be time to maturity. Now, I want to be clear. When you talk about time to maturity, we are talking about when the full period of agreement has been reached. So, for instance, if we're saying I'm going to invest for 5 years, the time to maturity is that 5-year period actually being honored. That's what it means. So maturity means it has reached its full potential. And then we've got I, which is the simple interest rate. Now remember, the I is normally observed on an annual basis. So we observe the interest rate on an annual basis. So we've got three factors. So these three factors will give us the following. One, the amount of interest. Now the amount of interest is calculated using the three principles, also the three factors above, which is the principal, the time, and the rate. And then we will then use this amount of interest to calculate the amount at maturity. Now remember, the amount of maturity is the amount, that very final amount, when the last interest is added, or when the interest is added after the time has elapsed, or the time has been fully utilized. And then we get that final amount, or some books might say net amount, some books might say final amount, but it's basically the amount you receive when the full period has been honored. Now, you've got the amount of interest, which is calculated using the following formula: P times T times I. Remember, I said in the previous slide, you need the principal, you need the time, you need the rate to calculate the amount of interest, which is, of course, now this is the formula, or this is the method of calculating that particular amount of interest. It's multiply, it is not plus. And then the final amount, or the amount at maturity, we then take that amount of interest, we add it to the initial amount, which is the principal, and then we get P plus I. But we remember that I is the product of PT and I, and then we've got this, and then we take out P as a common factor. We've got this formula, which generally we have the simple interest formula being given as A equal to P into 1 plus T times I. Now it is important that you understand this formula, ladies and gentlemen. So let's take an example. A bank customer invested 5,000 for 5 years at simple interest rate of 9.5% per year. Determine the amount at maturity. You can pause the video if you like, but I will solve the problem right now. Now, this is how we solve this problem. The bank customer invested 5,000 for 5 years at a simple interest rate of 9.5% per year. Determine the amount at maturity. Now, let's go to the solution. There are two options we could use here. Okay, before going to the options, here we do have the principal, which is 5,000. Why is that the principal and not the final amount? Remember, the principal is the amount that initiates the investment. So here, what we have is a bank customer invested 5,000, and the principal is the amount that initiates or that starts the process. So if we invest 5,000, this is the amount, this 5,000 then begins the whole investment process. Without it, there's no investment process to talk about. So that's why 5,000 is our principal and not our amount at maturity. And then we've got I, which is 0.095. We remember how to convert 9.5% to decimals. And then we've got T, which is 5. Now, it is very important that I note the part where I say T is always in years. It never changes. T is always in years. It's not in months, it's not in days. Even if you are given it in days, you have to convert it to years. Even if you are given it in hours or in weeks or in months, you must convert it to years. If you're given 24 months, you must convert it to years. It must always be used the units of years, not any other unit of time. So P times T times I is PTI or PIT or ITP, doesn't really matter. And then we multiply. Okay, see, I made some rearrangement there. Instead of putting a T, I put an I. But of course, that is allowed. If I had used PIT, it would have worked. It's not a problem. So we multiply these three primary factors and we get 2,375 rands. And then we take that 2,375 rands, we add it to the initial investment, which is 5,000, and then we have 7,375. This is the first method we could use, which is allowed. Second, of course, option would be to go straight to the formula, which is given as this, which is the formula we gave above. And then you just simply shoot straight and substitute, and then you go straight for the answer. This method is much more simpler than our initial or our option one, I should say. Let's go to the second example. How long will it take for an investment to double if the interest rate is at 5% per annum? How long will it take for an investment to double if the interest rate is at 5% per annum? Okay. Again, you can have an option to pause and solve the problem, but I will go straight for the solution. Now, we've got A, which we are told, we don't know what P is, but we are told whatever the value of P is, A is 2 times that. Now, I will pause that for a moment, and then I want us to view I want us to view this problem this way. Now, sorry about that. Now, here's what we have so far. We're told we are required to calculate how long it will take for an investment to double at a rate of 5% per annum. Now, if we were to use our BUCK system, first of all, we need to box the question. What is the question? How long will it take, yada, yada, yada. So we just want to know how long it'll take. Now, why do I understand long? Long means time. This is very important. Meaning, from the get-go, before we even know what is given, we know that we do not have time. Okay, let's analyze what is given. Okay, investment doubles. That's an important statement. To double. We are also told rate is at 5% per annum. Okay. What is the vocabulary? What is the vocabulary? First of all, we have is. We did say that is always represents equal to. What other vocabulary do we have? Words like double. Their mathematical vocabulary, or should I say two double. Yeah, I think that one now works very well. And what can we knock out or kick out? Now, in this statement, there is really nothing that we may say is actually irrelevant to the statement. Because if we were to say, let us remove the word investment, we don't care if it's an investment or not. but it would be wrong. Why? Because we do care that it is an investment. Because we want to know, is the money meant to appreciate or depreciate? So that we know what we're calculating. So, but of course, one may say that the knockout, you may knock out investment. Of course, it's a technical, linguistical issue, which we will not be part of. But I would say for now, there is nothing to knock out because there isn't really anything that does not relate to the question at hand, which is how long will some amount double? Okay. Now, I will do it in two ways. The first method is applying a particular one which is not in our slides, and then will be used. The second method will be the one which appears in the slides. They use basically the same principle. Now, here's what we have with us on our slides. We have I, which is 5% per annum. We have an unknown P. We want to calculate T, and we know that whatever the value of P is, A is double that. Now, many people use many different methods to calculate this, but the solution is always the same. Some people will say, let's let P be some value X, so that A is equal to 2X. Some people will say, let me take any number as long as it's positive and it's not 0. Let me take any number and say a number like 1, or let me write or, number like 2, so that A is 2 if P is 1, or it is 4 if P is 2. So either way, any number you take for P, A, we will double that if we're talking about doubling, as we are in our statement. Okay. So we've got A equal to P into 1 plus T times I. Now we want to calculate T because the statement said how long. So I will use the method where I said P is equal to 1 such that A is equal to 2 times P, which is 1, which is 2. So A is 2, P is 1, 1 plus T times what is I? I is 0, 0.05. That's that I've got 2. 1 times anything is 1. So I have 1 plus 0, 0.05 T. And then I have 2 minus 1 equal to 0, 0.05 T. Now remember what we said about solving or making variables the subject. So I have 1, 2 minus 1 is 1, I got 0, 0.05 T. Then I can exchange, put this on this side and this on the other side. The 0, 0.05 T, which is equal to 1. Then T is equal to 1 over 0, 0.05, which is going to be 20 when you press the calculator. Now, this is one way of doing this method. Any other way, we could also apply a method, say, let us say we use a method like another one may say, no, let's let P be equal to X, so that A is 2X. X can be any value. X can be any value as long as it's positive. And then we say we've got A, P into 1 plus T times I. And then we said P is X. That means A is 2 times X because we said A should double. Then I've got 1 plus T times 0, 0.05. Then I've got 2x equal to x into 1 plus 0, 0.05 t. Now I want to solve for t. And remember, what we say solving for t means? It just simply means make t the subject. It doesn't matter about the other variables. What you should be focusing on is making t the subject. Forget how many variables we have. Just focus on solving for t, which is the main problem. Now, another part we should try to remember. Another part we should try to remember is the value of x. Sorry, when trying to solve for the value of t, what we should do with x is, or the accepted method would be, try starting from the furthest value of t. Yes, this is further from t, this is even further, but the furthest of them all from t, we're only focusing on one side, we don't focus on both sides. The furthest from t on the side is x, sorry. The furthest from t is x. So we need to remove the one which is the furthest or most far. So how do we remove this one? By dividing throughout by x. Why did we choose to divide? Because x multiplies all of this. It doesn't multiply only one. If it was multiplying only one, then we would have taken to the other side. But it multiplies all of this, or it multiplies the whole side. Therefore, we are going to divide. Because it multiplies the whole side, we are going to divide it throughout all sides. So we divide it and then it cancels here. We divide it again here, and then we've got 2. Then we've got 2 minus 1, 0.05t. And then we've got 1 equal to 0.05t. Then we've got 0.05t equal to 1. Then we've got t equal to 1 over 0.05, which is going to be 20. So regardless of what value of p you choose, if you choose any value, you will always find, you'll always lead to the same conclusion in the end. So let's go back. Now, our second method, of course, it says that we're not going to assume any value for p, but instead, what we will do instead is to say that p takes some value which can be any value. So no specific value of p is made. Therefore, we don't assume any value of p, unlike the first method which we used, whereby we assumed p is 1. In the second method, we assumed p is some positive value x. Now we're not going to assume any value of p because we're not given p. But what we do know is a is double whatever the value of p will take. So we say it's 2p instead. And then we've got 2 is equal to 1, and then we take 1 to the other side, which leaving us with 2 minus 1 on the left hand side, which will be 1. And then we change sides, and then we got this, we divide throughout by 0.05, and then we have t equaling to 20. Now, we've got calculation of a simple interest, rate, when time is not in years. Now remember, I said your time should always be in years before you put it in the formula. Always should be in years. Now, the example that we're given here says determine the simple interest rate if the amount at maturity is double in 28 months. Sorry. So let's take again, going back to our example. In the first one, we're determining t. Now we're given t, but it's a bit tricky. We don't know what the value of p is, but we do know that a is double that. We are going to use the method that we use in the slides. But you can use any other method as well. It is acceptable. Okay. P has no specific value, but what we know about T is it's 28 months, not years. And then I is the value we want to calculate. Now we need to focus here because we cannot take T as it is. If we take T, if we say T is equal to 28, we're basically saying T is 28 years. If we write it like this, so this is wrong. This is very wrong. So what we need to do is to convert months to years. Now, how many months? If T was said to be 12 months, how many years would that be? It would be 1 year. If T was said to be 36 months, let's say 24 months, how many years would that be? It would be 2 years. If T was said to be 18 months, how many years would that be? It would be 1.5 years. So the question now is, how did you get these numbers? Now you'll notice if you divide here by 12, you get 1. If you divide here by 12, you get 2. If you divide here by 12, you get 1,5, which can be converted to 1 and 1 over 2, or 1.5. So how many months do we have in a year? 12. Hence we get these figures. If you had 12 weeks, how many weeks in a year? 52. If you had 36 days, how many days in a year? 365. But of course, the number of days is a matter of a different subject. Some companies would prefer lesser days than 365 because they take into consideration the public holidays and the weekends and so forth, and days they do not operate. So the days part is a matter of question, but for our course, we are going to assume the full 365 days. So what we want now is converting 28 months. Converting 28 months is simply 28 over 12 years, meaning it's going to be 2 years and 4 months. 2 years and 4 months. That is what it means. But of course, you do not need to write all of this. You can simply write it as a fraction as 7 over 3. T is equal to 7 over 3. So this is our time. So what it means is 28 months is the same as 7 over 3 years. So we've got A equal to 2P, P, which is unknown, T, which is 7 over 3, and I, which is to be calculated. And then you've got A, then all of this. Then I've got 2P equal to P, 1 plus 7 over 3I. Then after all this, of course, we can now now that we've established all of that, we have I equal to this, as we've established. Putting into calculation, we substitute, we get the values as we have shown. Divide throughout by P, and then we've got those values. We take one to the other side, and then we've got I being 42,4886. Sorry, 42,86%. And that is how we calculate for the interest rate. For the simple interest rate, sorry. And then we've got the compound. Now, the simple interest rate only adds interest once. We only add interest once. Whereas now the compound interest rate, it adds interest on top of another interest on top of another interest up until time elapses. Whereas the simple only adds when time has elapsed. So now compound interest is basically, as the words say, simple interest on top of another simple interest. So we break simple interest into smaller parts, and then we make simple interest add onto other simple interest up until the whole full period has been added. What do we mean? So compound interest is the interest that earns principal on accumulated on its accumulated interest. Hence we say it's simple interest that adds on, that adds on, that adds on. Hence we use the term accumulated. Something that accumulates is something that gradually grows over time. So if we take a simple interest of some first year or some first period, we will have, let's say first year. So we have year one, which is that. Now remember, we said it's simple interest on top of another simple interest. And our interest rate is always observed annually. And compound interest is no different. We observe interest on an annual basis. So on the second year, we move, what is the time frame between the first year and the second year? That is the time difference, it's 1. And this is the one that we add here in the place of T on the simple interest. And what is our principal? Our principal now is no longer the initial investment. Our principal becomes the money that we received in the previous year, which is A1. But what is A1? A1 is that amount that we have over there, which we add, and then we've got that. And then for the third period, we've got this same rule. Instead, what is the difference between, or what is the time difference between the third year and the second year, which is 1, which is what we put in here in the place of time on the simple interest formula. And then with A2, the principal amount which we see initially in the simple interest The principal amount has now changed to be the most previous amount. The most previous amount is this. We take that most previous amount, we multiply it with this interest factor or the compounding factor, and then we've got P into 1 plus A3. Now we do this, of course, we do this up until we reach the very last period, which we'll call the nth period or the nth year, which also will have our principal being the most recent. If AN is the nth amount, the most recent will be AN minus 1. Minus 1 meaning one period before or 1 year before. And then we've got that, which of course gives us this formula. And the compound interest in generally will become this, where M is the number of compoundings. Now, what does M mean? M means, since we observe interest rate on an annual basis, compounded meaning we are going to add interest on top of another. We are not forced to add interest annually. We may add interest many times in a single year. For instance, we may add interest every month, which is what normally happens. So if we add interest every month, that means in a full period or in a full year, in a full year, we would have added interest 12 times, because from January to December, that's 12 months, and adding interest every month means by the time you're done with the year, you have added interest 12 times in that particular investment. So the number of compoundings or the number of times interest has been added, it is 12. Your M then becomes 12. And since I is observed on an annual basis, you will divide that annual interest into those 12 periods, because you want to know, if I have 12% per year, how many or what is the interest rate for each month? Then it's 12% over 12 months, which is 1%. So 1% in January, I add 1% on the amount I added in January, I add 1% in March from the amount I added in February, I add 1% in April from the amount I added in March, and so on and so forth, up until you add the last 1% in December from the amount you added for an amount you have received in November. So it accumulates like that, and then you've got December of year one. Then year two, we add another 1% from the previous December, 1% from January, and so on and so forth. So that is what M means. M just simply means how many times are you going to divide this interest rate, and how many times will you add this interest rate to, this interest to this investment that you've made. For an example, a person invests 1,000 for 4 years at a rate of 5% per annum, compounded annually. Determine the amount to be received at the end. That is what we want to determine. Determine the amount to be received at the end. Now, here's what we have. We've got the principal amount, 1,000. We've got I, which is 0.05. We've got T, which is 4. And then, since the interest rate is compounded, which is the most important part, this is what differentiates a simple interest from a compound interest. Since we are told 5% per annum compounded annually, that compounded annually shifts it from simple to compound. And because it is compounded annually, and remember the term annual is synonymous with the term year, it means we will add interest once per year, or the interest will increase once a year, and therefore M becomes 1 in our formula above. And given the formula, we have this: P is 1,000, M is 1, I is 0.05, T is 4, and then this becomes our final amount. Let's take another example. Now we want to calculate the principal. The amount invested 8 years ago at 9% per annum compounded monthly. Now, we stop there. The fact that it says compounded monthly, it means it's no longer simple. It's a compounding formula. Yielded an amount of 10,800. Yielded, meaning whatever, there was a process. The word yield, it means the results that came out after a particular process had taken place. So in this case, what is the process? The investment process. That is the process we're talking about. The investment, that is the process. And then the yield was 10,800. That is the results that came out of all this is 10,800. At maturity, meaning after the full period has been said. Now we're not told that that 8 years is the full period. We're only told that this investment started 8 years ago. Sorry, before we go to the solution, determine the amount of interest received at maturity if it is to mature in 8 months' time. Okay, 8 years ago, the investment was made. Now, the investment will be was made 8 years ago, but will mature in less than a year, that is in 8 months from now. Now, what we want is to determine what is the full maturity period from when it was first made to when it will be last received, or that particular day it's supposed to be taken out, or in our, or what we say, the last day when it will mature in 8 months' time. So solution, P is unknown. Why is P unknown? We will discuss that. M is 12. Why is M 12? Because we're told it is compounded monthly. And how many months in a year? 12. So M becomes 12, meaning it will be added 12 times. And then we have I, which is 0.09, because we're told it's 9% per annum. We've got A, which is 10,800. And then we've got T. Now let us discuss that T. Let us discuss that T just a moment. We are told we are here. This is the now. This is 8 years ago. Now, timelines are very important in financial maths. So 8 years ago, some particular investment was made from here up until now. And now, in a short span of from here to here, it's 8 months. Meaning, this is when it matures. Now, we know the time period now is 8 years and 8 months. We don't know what the initial amount was, but we know that at some point it matured to this. This is what the statement says. It yielded this result. Now, what do we know about time? Time is always in years. We already have 8 years, but we've got 8 years plus 8 months. 8 months Converted into years, what do? We divide by 12. And therefore, we've got 8 months. We've got 8 months. Sorry, 8 years and 8 months. So we've got 8 plus 8 over 12, which is 26 over 3. 26 over 3 years. And this is the value that we will be putting in our calculator. So we want to calculate, sorry. Now let's go back to the statement. The question now says, determine the amount of interest received at maturity if it is to mature in 8 months. So we want to know what the amount of interest, that is the objective. That is the objective. The amount of interest is what is to be determined. But the question now is, how do you determine the amount of interest? Interest is calculated the same way. It's the amount you gained minus the amount you put in. This is the revenue minus the initial amount, or the open amount, the opening income, sorry. So this is how much you have made on this investment. That's the interest we're talking about. And then now we say, this would be easy because we already know what A is. It's 10,800. But the question is, what is P? P is the problem here. So what is P? P is going to be calculated, P is going to be calculated using this formula. Now, I always say, to make things easier, but of course it's not a rule, but to make things easier, I always say, just press the calculator and see what you have here. So we're going to use the calculator to calculate this particular value here. So we've got 1 plus this is 0.09 over 12 and to the power 26 over 3 multiplied by 12. And what do we have? We've got 2,175,132,415. Let's write this as it is. Now, try, or should I say, avoid rounding off. You never round off before you finish the answer. You always write the values as they are. Then we divide all of this P. We've got 10,800 divided by 2,175,132,415. You divide, so you've got 10,800 divided by 2,175. 132,415. 175, 132,415. Then I've got 49,675. Now I round off here. I want to stop at 1, but I look at the following one. 4. 4 may increase to 5. So I look at the following one. It's 9. 9 rounding off 4, we have 5. And then 5 rounds off 1, and then I have 2. So I have 5, 2, 2. Now I have the P. I have this P that I wanted. So I then becomes A minus P, which is 10,800 minus 49,665.22. And then $8,034.78. This is, of course, the method that we'll be using in reality when making this type of calculations. But let's look at it in the simplicity that was used in our slides. Now, in our slides, we have that, but we'll note that we didn't actually simplify the time. We kept it as it is, which is not a problem. Then using the box system. Now the box system, remember, it's something that we used in word problems. Now the box system simply says we want to solve. We want to break down this statement. When solving this equation, we want to break down the statement. And the first part we have to know when using the box system, we need to know what the question requires us to do, so that we know what we need and what we do not need from the statement. And what the question requires us to do is to calculate the interest rate. Everything that will be do must affect the interest rate somewhere, somehow. And that's the formula, of course, but we need P. P we are not given, but we can calculate because we already know the formula that is used in P. And we have now the amount at maturity, we have the time, we have the rate, we have the number of compoundings. Now, we've got this. We use the formula to calculate P. And of course, I did say that preferably that's the way I would have done it, but this one also works, of course, if you trust yourself using a calculator. And then you've got 49,665, which is the same value we got. Then the amount of interest, which is the main objective of this question, is then calculated as this value. You subtract, and then you got 5,079, 78 or 79, depending on whether you use the decimals. I did not. But of course, the value is still the same. Now, let us use calculating time. How long will it take for an investment to be 50% more than the initial investment when the investment receives 15% per year converted monthly? sorry. Now this one is a beautiful one. Apply the same principle, but uses different terminology. How long? Let's look at the question again. How long? Meaning we are looking for time. We are already given the rate, which is 15%, compounded or converted monthly. Yes. This is what we have. So the formula is calculated using this formula. So there is one crucial part though. The question says, if investment is 50%, sorry, if I think if it's final amount, but in the nutshell, if the final amount is 50% more than the initial investment. So if the final amount is 50% more than the initial investment, this means that if you have A, this is the investment. Now 50% more, meaning plus 50% of P, or P plus 0.5 P, which is going to be 1.5 P, should increase by 50%. So how long will it take for it to reach this amount? So given the formula above, which we have 1.5 P, which is our A. We have the P, or you can use the X if you prefer. That works as well. Or 1, use 1 instead of P. That also works. Then it was 0.15 over 12 to the power T times 12. Now, again, which variable is the furthest from T? It's P. So we divide by P throughout because P multiplies everything on the right-hand side. P multiplies everything on the right-hand side. So we divide by P throughout. We only divide by P throughout because it multiplies everything. So because it multiplies everything, we divide by it everywhere. So we've got 1.5 equal to 1 plus 0.15 over 12 to the power 12t. Now here's the problem. Our exponent is the variable. How do we remove an exponent which is a variable? Now go back to what we said was going to be crucial in financial maths, which is how to convert exponents which are variables to and make them subjects to the formula. We introduced logs. Now there are two ways that I introduce logs. I use the natural log and the normal log, and I'll show you, because I once said they are the same. You can use any of the two. I'll show you why they are the same. Let's use the ordinary logs. I will introduce log 1.5 on the left. I will introduce log of this on the right. Okay, let's see if we cannot make this 1 plus 0, 12. See if you cannot get, so it's 1, 0.0125 to the power 12t. And then applying that log 1 rule, I think it was log 1 when we were establishing the log rules. We made it log rule number 1. And then now t is no longer an exponent. We can now divide by anything that does not have t. So 12t is equal to log 1,5 divided by log 1,0125. Or you may say, if you prefer, 5 over log. This is an optional, it's not divide, by the way. It's optional way of writing it. You can write it like this, or you can write it like this. Any of these two applies. So let's forget this one. Let's forget this one and focus on this. Now, let's see what the calculator says. The calculator says, if you say log 1,5 and then log 1,0125, you get 32,63952,146, yada yada yada. But you can still say log 1,5 or log 1 plus. This is the same thing as what we did here, just trying to emphasize that in any of these two ways, it still applies. So you can use this or you can use that. It doesn't really matter. But if your decimals will be long as this, then preferably keep it this way to avoid any decimal errors. So, and then we've got this value, and then we divide by 12, the 12 that we have here, so that t is 2,719960122. Let's keep it like this. Now we know that t is always in years. So this is 2, something something years. Meaning this is some fraction or portion of a year. The question is, what is that portion? That's the question. So we've got 2 years. This is the 2. And some 0,719960122 year. But we want to convert this so that it's in a readable sense, because you do not say to a client, I think you're going to pay your money in 2.5 years. You say 2 years and 6 months. So you always try to make sense, or you always try to interpret it in a way that it makes sense to the person reading your work. So we convert this to a period we can all understand, preferably the months. So you've got 2 years and whatever portion of a year. So because, sorry, yeah. So because we already know that this portion here is a period, this is already in years, so we've got 2 years here, and we are going to say now we have 0, all of this. So we remove this 2, we have 0, we remove this 2, and we have 0, 0, all of this. We multiply that by the number of months in a year. If you want to convert it into weeks by the number of weeks in a year, if you want to convert it to days by the number of days in a year, but I'll convert it to months. I've got 8,6, and then I convert that completely. I round off to the nearest whole number, which becomes 9 months. So it will take 2 years and 9 months, meaning I multiply all of this by 12. Now, after all this is said and done, I have 2 years, which I got here, and then I have 9 months, which I got from the decimals. Now, you remember, I did say that A is just 0,5, a portion of 0,5, and then we put in it in the formula, we divide by P, we get that. Now, here's this part that differs from what we did. Here, we are now introducing natural logs. We are introducing natural logs. And then, as you know, natural logs, they're still logs. They operate in the same rules as every other log. But now you will notice that here, we did not convert it to that 1,025, because I said you have an option of taking it as it is or converting into decimals. But if you're going to have a lot of decimals, then keep it as fractions for simplicity and avoiding unnecessary decimal errors. Then you've got that value. I read the ... meaning there are other values that are at hand. You do not round off. I repeat, do not rush to rounding off until you reach the final answer. Then we divide by 12, and then we got that. And then we remove the 2. We simply subtract this value so that we have 0. So we've got 0, 7199, yada, yada, yada. Then we've got 2 years. We multiply whatever remains by, we multiply dot 07199, dot, dot. We multiply that by 12 so that we convert that portion of a year to months. So we've got 2 years and 9 months. And that is how we get the period, which basically means that it'll take 2 years and 9 months for this amount to increase by 50%. And ladies and gentlemen, that is all for today. Thank you very much.